I'm just going to briefly cover what we did last on the last class. So how many I see like only 2 or 3 faces, right? Who were there in the last class. So we went through why it's important to do a modular design and how to take advantage of modular design. When we do deployments on the cloud, right? So we went through, and basically I'm going to go through this, this terminology that we use when we do deployment in cloud. But basically, a few slides back, this was the example we took, sort of a monolithic legacy style application where everything is crammed together. This was a classic example of from the movie Jurassic Park. Where once you bring down the system, the whole system was down, basically. A single point of failure, no redundancy, no disaster recovery, nothing like that. Okay. And then basically when we went to this, we said like, if you look at it, each of this, component or each of this application, we could spread it out into a separate microservice, right? A microservice for this dinosaurs area, for this T-Rex part, for this whole part, for the vehicle, the lights on the vehicle, the speed on the vehicle. So for each of this function, basically we could break down this monolithic application into a small services, which we call as microservices. And how do we talk about microservices? How can we deploy that? We talked about containers, we talked about the emerging deployment techniques and so on. So coming to that slide, this one. So this, it captures pretty much in one slide the whole taxonomy around cloud services. So starting from the left-hand side, the leftmost side, that's the traditional on-premises, which is basically you're building your application, you testing it on your computer, on your desktop or laptop, and pretty much in production when you deploy, it stays the same. Okay? That's your target environment, which is a server or a desktop, a physical box basically. Then came the infrastructure as a service. It started somewhere, I think, when Amazon started doing it way back in 2001 or 2, I believe. Also called as IaaS. So pretty much, use this pizza as a service analogy, and you see, for making a pizza, basically, if you have your own shop, you need everything. On the left-hand side, you need a gas, oven, the utility, the pizza, pie, and everything, toppings. You also need a beer, friend, conversation, blah, blah, blah. The infrastructure as a service, think of it as a communal kitchen. So basically, they will provide you, or somebody will provide you, the utilities at the oven. You bring your pizza, you bring your friend, beer, and whatnot. So that's infrastructure as a service, which is what we're going to look at an example in subsequent class. Bring your own is essentially, you have the system provider that provides you the gas, the utilities, the oven, and the fire. You just take your pizza, pizza pie, or like a frozen pizza as an example. You bake it there, bring your friend, beer, and so on. So that's a container as a service. So that's basically, removes the hassle for you, about all the infrastructure. You basically bring, so container as a service is nothing but you bring your application, put it in a container, and then, run with it, right? So that's, I'm going to touch today with the actual demonstration. And also platform as a service, or PaaS. So it's like a takeaway, basically. Analogy is like a takeaway pizza. Basically, everything the service provider is providing is all the way up to the pizza. You just go in, pick up your pizza, bring your beer, friends, eat it. So that's becomes the PaaS, or platform as a service. After that, and these are the most recent addition, function as a service. Which is equivalent of a restaurant, where you have pretty much everything, electric, gas, oven, fire, pizza, beer, You just go in there, and you bring your conversation to the table, and you enjoy your time there eating pizza. So that's an equivalent of a restaurant. And then last is the party, which is software as a service, which is pretty much everything is there. You just go in, bring your conversation, and have fun. Latest example of SaaS is Microsoft Office 360, Salesforce.com, and there are many more. And then there are various, I think there are a lot of take on SaaS these days. Research as a service. We spoke about it back with Vinicius. That we could develop research as a service, specifically the time series thingy, and so on. So any questions there? It's important that you guys get this concept, because in future, if you want to, start your own website or whatever it is, right? Based on the load, that website or the web app is going to have, you could decide, which model you're going to use for a deployment. Whether it has to be infrastructure as a service, that's going to be costly. Infrastructure as a service means they are providing you the box. You need to manage everything. They're providing this physical server. You have to manage your operating system. Start from their security and everything. Okay. Versus container as a service, they provide everything. You just bring your application, put it in a container, and run it. So that's the most lightweight, recommended solution for a simple. Yeah, please.
Yeah. So see if I'm in the same ballpark. Software as a service would be like our email.
Yes.
Because it's something that I just use, everything is there, I don't have to configure anything, I just have to send emails and receive emails. Now, function as a service.
Yeah.
Well, platform as a service, this would be some white label thing that I would input my brand. Let's say, that I'm on eBay, and I create my page to sell things.
Yeah.
This would be a platform as a service.
Yes.
Okay.
Like that. Yeah.
Containers as a service. This would be someone is going to give me. I do have an application, but I don't have the computer. I don't have the internet. I don't have anything. I'm going to put my application. Someone is going to give me this thing.
Yeah.
Correct?
Yeah, conceptually it's like that, yeah.
Okay.
Basically the shipping container is available to you, put all your stuff, and then the container has its own life.
Okay, so I don't care for infrastructure. This would be more or less like infrastructure as a service. What is the difference between infrastructure as a service and container as a service?
Difference is that with the container as a service, you don't have to worry about operating system. So with the infrastructure,
okay,
you are responsible for operating system and everything. The difference is also like infrastructure as a service is like the entire virtual machine is yours, right? That one single core virtual machine or 10 core virtual machine is yours. You do whatever you want to do it, it's all your responsibility. Everything is yours. With containers, they basically provide a virtual machine that has operating system and everything, including all the orchestration software, everything is there. You just bring your container. So the only drawback here is that although there could be more than one container, there could be like thousands of containers, but they all have to share the same operating system.
So basically it's just like a computer with Python, and I have my Python application that I'm going to put there.
Yes, exactly. Python and Java, all sharing the same operating system.
Okay.
Yeah, and then the platform as a service is also an interesting offering. Like, say you don't want to worry about managing all kind of stuff. Like, as an example, we go back to that Tiger Style project that we did, right? So we have to manage pretty much everything. We create an infrastructure. Basically, we created an infrastructure. We built out the whole EC2 instance. We figured out how to configure that. And when the load went up or down, we have to add more EC2 instances. If you want to delegate all of that responsibility, choose platform as a service. It's very straightforward. You could, and I'll show that as an example, where you can up or down the number of instances that you need.
This would be the Amazon Elastic Beanstalk. That I just put some Flask and they handle the computing, the size of the computer, everything.
There is a new one though. I think Google started it, so now everybody's following it. Which is like, you see, earlier it was EC2 only, Elastic Cloud Compute, right? Then they added EKC or ECK, something like that. Elastic Kubernetes Cloud or Kubernetes Compute. Similar on Google. So Google has like 3 different instances. One is called as the Google Cloud Compute, GCC. The next is the Google Application Engine, which is equivalent to, I think, the PaaS. And then they introduced something called as the GKE, Google Kubernetes Engine, which is equivalent to the Container as a Service or PaaS. So I'm going to show you guys in the next slides. We'll briefly go over the container, how to create containers, and then I'll actually do a full demonstration of deploying on a PaaS, which is Google Kubernetes Engine, GKE. All right. No questions here, right? Good. So I think last time we spoke about, just going back. That everybody should have at least set up their environment. So the thing that I wanted you guys was to make sure that you have signed up for the free tier account on Google Cloud.google.com free, and have access to the console. So that will be easy for you to play with it if ever you want to do it. But at least here I can show you how to do it on my own account. But it's very straightforward, very easy. Just pick up your Google or Gmail email account, sign up on that, and then it will guide you through the process. It's very straightforward. Okay. So I want to do, so when we talk about containers, right, what it is. So I think there's very important concept that I want everybody to understand, right? Once you write an application, and this is what we faced with Tiger Style, and probably we also had a similar issue with the time series project. We have to make sure that the application is runnable. Think of it this as a container, the computer as a container, and whether the application can run on its own or not. Whatever is required, the environment, the setup, everything should be sort of a sandbox. If you're able to achieve that on this computer, you could do that on the container as well, right? So container has its own peculiar stuff, and I'm going to go over that. So this is, these are the steps I'm going to run. And before that, let me show you the code. I don't know if I think I've shown it last time. So another drawback I noticed was that Windows is not a friendly software for containers. So I switched to Ubuntu. I don't know how many of you can do Ubuntu, but this Mac OS easily supports containers. And when we do actually do the demo for the PaaS deployment, we don't have to worry about it because we're going to use the Google Cloud Shell. So everything is built into that. But if for containers, basically you have to do it. So every container, hosting. Okay, so every container app has to have a Docker file. Now, I think I went through what's Docker. Some of you who were there in the last class. Docker is, another software that helps you deploy, in containers, deploy your application into containers. So that's basically what it does is it tells you, what's your base image. So here I'm saying, my application requires Python 3.7. That's my base image, and then few instructions on the to Docker how to create my container. So I'm telling them, okay, create my base directory, which is book catalog/app. This is going to be my work directory as well. Copy everything that's there in my project directory to this folder, and then do a pip install. So as most of you know, pip install is basically resolving all the dependencies. So I have some dependencies in my Python package. Basically, I think only thing is there is this Tornado. Tornado, by the way, is a web framework. People who have familiar with Flask, some of you are in Python. Flask is a development web framework. Similarly, Tornado is another one, a much better version than the Darrow. Well, I kind of, I don't need to do, put it behind Minicon and all of that, or Gminicon. So Tornado is very simple to use for microservices, and that's why I chose it here. So the whole code is essentially, arrange it as a microservice. So if you look at my code here, API.py, basically it has like 4 calls or 3 calls. Add book is to add a book. Del book is for deletion of book, and then get books is to get the books. Yes. Yes. If I just go to oh, let me take this call. That's right.
I think this is without hyphen. I'm in 0047.
Oh, sorry. Yeah. Okay. This is the one I think. Yeah. Can you see this? It's also there on the slides as well. I think I posted them on.
Is it on GitHub?
Yeah, the code is on GitHub. So if you look in the slides that I posted onto the meetup as well, I don't know if you guys got that. Okay. Perfect. Yeah. So this one here, there's a link here. Okay. So I'm going to go through this step by step and show you how I did the deployment. Let me just make sure I can increase the size of the font. How do I do that? I don't know how to increase the
No, you diminish this.
okay, all right, let's go through this. So, I think you guys get, you guys can look into the code, but let's go into this one. So basically what I did was, you can, I don't know if I have this, okay, I'm going to remove my, okay, so just copy over this guy. Okay. So I got everything here. I go to the folder and then I say Docker build. I'm just going to copy this over. Okay. So what I'm saying is I'm going to tag my build with this. So physically, when I talk about a Docker image, it's not a physical binary yet. It basically creates a sort of an envelope, put everything in there. That envelope is nothing but a JSON signature. And it assigns an ID to it. It's always opposite secure and all that, it encrypts everything. But you can read it if you want to. So up until this point, as soon as I hit enter, it's going to pull out everything that it's required, and it will create an envelope with all the, all the JSON signatures. Sorry, you had a question?
I don't know how much further have you got last class, so I don't want to interrupt.
Yeah.
But can I?
Yeah,
I'm going
please.
to ask a very first basic question.
Right.
One, I see that you have base between parentheses. Is this a virtual environment that you have in your local computer, or actually are you connected to the Google Cloud already?
No, not yet. This
So-
is all local.
So base, it will be the name of the virtual environment that you created in your computer.
Yeah, that's right.
Okay.
Yeah. Base is my Python
And whenever you wrote the last
command. Yeah.
the last command,
Yes.
you wrote Docker
Build. Yeah.
build catalog 1.0.
Yeah.
So this at the boot catalog 1.0. What is this file?
Okay. Yeah. So Docker is the
Docker is the file or the command?
no, Docker is the command. Docker is
The
the
command.
utility that we're going to use, and it's an industry standard utility. And then there are others, but Docker is way ahead of everyone. So Docker allows you basically to containerize your application.
Okay.
It allows you to create container and deploy it, and basically all of that. So Docker allows that. So Docker, what I'm doing here is I'm building a container.
Okay.
I'm saying I'm tagging it with this name. I'm just giving my name. It's not necessary. You can even get rid of all of this. Where you could just call it, give some name as an application, and then the last part, column 1.0, I'm telling it, it's going to be version 1.0.
Okay. So, but when you build that,
Yeah.
have you, for example, I see that it's written there Python 3.7.
Yes,
If I wanted to build a Python 3.6,
you can.
how could I do that? Where is the code that shows that you should build a Python 3.7?
Yes, so here, because right now I'm having in my local, I have Python 3.7, so I use it. So if you want to change it, let's say you have
Okay, so you are in the
Docker file.
and he's going to understand. He's going to read this file.
Yes.
When you say Docker build,
Yes.
he's going to look in that folder for a Docker file,
Exactly.
and he's going to build that. What is
Yes.
written there?
Yes, that's
Thank you very much.
Yeah, and so this is very important. Every time you are containerizing any application, it has to have a Docker file. That's how Docker understands everything. It goes through this file, reads the content of the Docker file, and then construct a container.
It's in the same directory as you are running the command.
Yes, exactly. So here, if I go in, you see, it has Docker file here. Okay.
Now, just a dummy question, maybe
Yeah.
this is running on the cloud right now, right?
No, this is all on my local.
Local machine.
Yeah.
So the container is local.
Container is all local. I haven't yet ran the container. But the whole idea behind this is that before even you ship your application to the cloud, try running it locally. Yeah, that's the purpose of this, And so that I want you guys to be, get familiar with the whole idea behind containerization. And I can do that also on the Google, I don't have to do it here locally. But just to give you guys, some idea around what container is and how to play with it. I'm creating it as a local.
Okay.
Next, I want to run it now. So here, so there are two examples there. One, I'm just running it as a one container, but if I want, I can run a multiple container, all on command line. I say here -name container one. What this do is -p is basically I'm telling use the port number of this host, okay, mapped to port number 8890 on the container. Alright, so why is it that? Let me go back to the code and show you that I'm using here in the Docker, I'm saying expose port number 8890. Why? Because if you look in here, I have said that I want to listen only on 8890. Alright, so in my application I'm using the specific code. I mean, it's hard coded, it's not a good practice. Normally you put it in some environment and it will get picked up from there. But just for for the sake of experimentation, so this is the port number I'm using in my app. Accordingly, in the Docker file, I'm saying I'm going to expose this port for this specific container, and then when I'm running the container here, I'm saying use the port number 8890 from the container, but map it to 8880.
Excuse me?
Yes.
When you're launching two instances,
Yeah.
then also you're mapping it to the same local port. Is that okay?
Yeah, that's fine.
Okay, so
Yeah. So
how
we
would
go-
you distinguish?
Yeah. So basically, what happens is here is like this is here. So let's say this is your computer or a virtual machine, right?
Mhm.
You could have basically as n number of containers.
Okay.
Okay. And then there is something called there is this interface between your OS. So this is your OS. Okay. And this is the Docker interface. Let's call it as a Docker interface. And these are the containers, C1, C2, C3. Alright. So each one of these containers there is a port, entry point. We call it as an endpoint also. You can call it as an endpoint for each of these containers. How do you access these endpoints? There has to be a connection from here to here, right? And then you as a user, you can only interact with the OS, right? So you are going to connect here. So you say, give me this port number on the OS, which is 8880,
Okay.
right? So all the traffic will be routed here. And then it's up to the Docker, container management software to figure out, it will have its own internal load balancer, similar like load balancer, and all the traffic, because all of this container has to be exact image, exact replica. So they have to be, it's listening onto the same port, and accordingly, this guy will, based on the traffic, it will route here, or here.
So in the same container, I wouldn't be able to bring up two different applications. If that's the
No, you
case.
can't.
Okay.
If you want, you can wrap that application, separate application as another container,
Okay.
and you can do that.
Okay. Thanks.
Okay, so if I do have two different applications, I can put one in one
One
container,
container.
one in another container. The client is going to
Yes.
do a request. The containers are going to do different jobs and output
Yes.
the result for the client.
Exactly. So think about this Amazon.com, right?
Yes.
There are like, at least 500 microservices on that one single web page. Right? When you go to Amazon.com, everything that comes on that Amazon.com is a microservice, each one running on a container, separate container.
Okay, so when we say that we have microservices, one microservice is what is inside one container.
Correct.
Okay.
Yeah, and then if there's a heavy load, so it can create a swarm of containers.
Uh-huh.
So like there could be, depending upon how much is the activity on the website, a lot of people are interested in only buying, say, Amazon Eco Speaker, right? So that one microservice would just fetch the eco-related data, and if there are like thousands of people trying to purchase that, then the container would scale as
Okay. So using this example,
Yes.
let's say that both of us, we are entering your app
Yeah.
and we are doing the same request at the same time.
Right.
So if we are in an elastic world, this would be duplicated
Yes.
to attend both of us at the same time.
Yes.
And that is the fundamental concept of microservices, because of
Exactly.
which we are doing it, right?
Yes. Yeah. And that's the whole idea behind it. Microservices allows you, you go back to that example of monolithic application, where it just literally, it's not possible for you. Versus with microservices, you could, you could basically, and that's the whole idea behind, it's self-contained, it's stateless, right? So you can mutate as many microservices or as many services depending on the load. So this code actually that you're looking at is actually a microservice code. Right?
Can you just go through that microservice?
Oh, that part?
Yeah.
Let me quickly go back to that slide. Okay. Yeah.
I think
So-
you want to go through the code, right? Not the
Yeah,
concept.
just know the idea.
Oh, okay, the code, okay,
Yeah.
I'm sorry. I can go through it.
So
So,
like fundamental idea, we have full picture,
yeah, well,
if you don't mind.
okay, we'll try to. Okay, we have time today. I wanted to call literally like 10 more slides, but let's see how. So, microservices, basically it can be, well, first of all, any microservice, not necessarily any, but at least in this example, and this example is like a web app, right? Say I want to read a temperature remotely somewhere. So I can encapsulate all of that as a microservice. Okay? Or on Amazon.com, shopping cart is one microservice, but inside there could be it's aggregator microservice, shopping cart. In that there could be another tons of like one is just based upon the number of items, it automatically calculates the cost and the shipping and the tax. Okay, that could be one microservice. There could be another one which will just take care of your shipping requirement, whether you want 1 day or 2 day or 3 day. So that's in a nutshell is an example of microservice. Okay. Now how do you implement that? So basically you need a web framework, right, which could support some sort of a very faster request response pattern. Okay. So in this case, I selected Tornado. So let's look at the code.
Right.
Okay. So what I do is Tornado, and you can do a Google here. Just look for tornado.web or Tornado web. It's a nice library that basically have, it's I would say it's better than Flask, but some people are saying it's better than Flask. Flask is a development web framework which has both the client and the server side. So what it allows is like, because it's a development web framework, as you are writing the code, you could see things changing on your web page. So you just make some change, save it, and instantaneously that will get reflected on the web page. Okay, so that's the advantage of using Flask. Versus this one, you have to rerun it. But this is very much very resilient. It's not trade set, but with Python we don't care about trade set yet. At least it's Python is inherently it's not multi-threaded application. They just do the time slicing. So if you look at here, so what I did was with Tornado, I declared there are 4 endpoints. I said V1. So you can call this as an aggregator microservice. Inside this microservice, I have 4 microservices, and each of these microservices is associated with a handler. So I'm calling. This is the handler for the version. This is the handler for adding a book. This is the handler for deleting a book. This is the handler for getting the list of books. All right. And this is a simple 3-line code where I'm creating the app. I'm going to listen on this port number for this app, and then I'm going to a loop.
Okay.
All right.
So you have 3 microservices running on the same port now, right?
Yes. Because this is an aggregator. This guy is an aggregator. So all the traffic is coming to the aggregator port, and then it's routing to the individual microservices.
What is that?
Yeah. So in this code, right, I'm saying this application is having this many services. These are the endpoints. /v1 /v1 add book, and against each of this endpoint, these are the handlers. Now let's look at the handler code. So this is the handler code. Again, it's using the tornado.web library. And see here, this is my base class. I'm inheriting this, the whole infrastructure that Tornado provides, right? And so in here, I'm saying this is there's many classes I created. So for version, I decided to keep it separate because it's not doing anything. But for the other stuff, like this is my base class. And for air handler is inheriting my web handler, so I don't have to take care of initializing and everything. I'm basically saying, when I do a get call, I pull out, this details from the response that I get. Similarly, when I do delete handler, so it's the same terminology for any web app, which is a request. Request is get, and put is another kind of a request. And you get the HTTP response back. So a very small piece of code, just wrote it for this specific tutorial or class. Alright, and then last is, sorry.
Just a second. So, okay, so you have the first class is whenever it starts running, it's going to say, look, this is a simple microservice v1.
Yes.
That's the output for the client.
That's right.
And then I'm going to put slash my.
So actually, I can show you how we're going to see. Just hold on to that for like in.
Okay.
Yeah. All right. Let me show you that. So you're coming back here. Right. This one. I'm going to run it now.
So the Docker itself is responsible to launch the application as well, right?
Yes, exactly. Okay. Right. Oh,
So you can look up.
I think no, I didn't add 1.0. Maybe I should update this. Okay. So it's running now, right? This is the ID of the container. All right. Now, if you want to see, and this is like I didn't show you all Docker images and all of that, which should have shown you like this was the for this book catalog with tag 1.0. This was the image ID. All right. But I can see how many containers are running now, so I can just say Docker ts -e. So it's right now running this guy, okay? Ignore the command and all, and this is the container ID. Now if you want to test it, all I have to do is, now you all know that I've exposed this port number, okay? So one way of doing this is curl -i http localhost colon 8080 v1. Alright, I got the response, okay, blah blah blah, sample microservice. Alright, and I can do that same thing here, which is http localhost 8080/v1, and this is it.
Yeah.
Read books. Oops, sorry, did I read? Let me just look at the code, what I So it's very fast, you know. This, like, you see 3 entry there because I initialized the library with 3 books. But I can add books here. I could just say add book, author, equal to RNN, and title equal to, let's say, hot chips. Alright, so we added one. If I go back and say get books, so hot chips is added. Right? So, you know, so that's the beauty of microservice. It allows you to run stuff in a faster way. And because it's self-contained, very small code. And you can think about, you know, that's how Amazon has that scaling of operations. It's really very, very fast. Sorry, yeah.
Yeah, so you type in the URL
Yeah.
the name hot chips, but you had some. How was the code that you typed? Slash add books.
Yeah, so slash add books. So this is you guys have heard about RESTful interface, right? So this is the way. This is essentially what is called the RESTful way of dealing with an application, right?
You also like allow it to have like no slash and all those.
Yeah, all of that. Yeah, I can put in as many as I want, you know. But yeah. Sorry, go ahead.
Yeah. So, but the fields author and title.
Yeah.
Where is that on the code?
Yeah. So here. So if you look at
Just a second.
handler.
Okay,
when I say
yes.
add book, right? Add handler here. So it says look for title, look for author, okay? And then result is basically this title and author, it's adding it to the books. So it goes into the book library or the list of books and add this, the stuff that I just passed on. All right? Yes. Please.
Well, actually, I know some answers, so things but it would be things that I would ask.
No, please. Yeah.
So, can you parse not one book but two or as many books? How can I parse multiple books?
Not in here, but if you want, you can basically. There's a way of doing it. You can write a simple shell script. Okay, and for each of these shell script, you call. So like here, if I want to call with my here, right? I could do curl -I v1 add books, and in a loop, you could call this multiple times, and that way.
So I can just put a for loop.
Yeah, it's a for loop.
Great.
You could just basically read it from a file, author and title, put it all in the for loop, read one line at a time, pass it on to this command, and boom, it will go ahead.
Fantastic.
Alright. So
Now, where does it store right now? Is it, so once you come out of it, all this will go with it?
yeah, I didn't put any database or anything, but you could. I could put SQL, DB, and so on. But this was just to demonstrate, a simple container, so I didn't add any fancy stuff. Okay. So coming back, so this is another number of commands there, which you guys could try. Like I showed you, and then I know, of course, it's good to kill the Docker container. So if I go back here,
So what interface is this that you're typing in?
oh, this is a terminal. It's like an Xterm. So Windows command prompt. As Windows is very command. So I would recommend if you're playing with Windows, there's a nice terminal called Cygwin. Yes, you should use Cygwin on Windows, or there is one SuperShell or something like that, which is really fantastic. I've used it on Windows. It allows you to emulate all the Linux stuff on Windows.
What is it called?
SuperShell. I think yes.
So some of the things, Cygwin, I don't know, some reason don't support or whatever, like for example, SFTP or something.
Yeah.
When I try like on Windows regular, It works on the CBD, it wouldn't work.
No, so Sigwin has a separate package, so you have to download that package also.
Ah.
Yeah.
The same thing for Docker, you
Yeah.
need to separate package.
Yeah, so here's the problem with Docker. Docker is having some animosity against Microsoft Windows, I think. So they don't support Windows. They only support, not the home version, they only support the professional Windows or the enterprise version of the Windows. So most, yeah, go ahead.
Sorry, in supposing I cannot just run on Windows, even in that interactive.
No, you can. So, yeah, so actually I did, if you guys want, I think I have on one of the website, and I was going to talk about it. So I did push my code to the Docker Hub. So this is a ready-made image there, bootap/-v1, which you guys want to run it, you can run it. But this one is, it requires, Penguin, it's a Linux version of the image.
Yeah, you just go into GCP VM, right, and then we can run there, right?
Exactly, yeah.
So the aim of this class is that only, but
Yeah.
you are into the GCP.
Yes, so I'm going to show you now the GCP version.
So right now you have Docker and Sigwin?
No, this is all I'm using the Ubuntu. This is equivalent of Sigwin, but it's inbuilt into Linux.
It's your own operating system, yeah, it's not.
That's right, yeah.
So is the first line of that, what clone that command actually install some kind of, the interpreted file on your machine, so it can explain this like a curl or docker was command, right?
Yes.
So after you've done it, how do you need to clear, like how to remove them more, and is there any where we can find a manual that we can
Right.
check the whole command, so
Yes.
under that environment?
Oh yes, absolutely. So you can go into, I have, so docker.com, if you go docs.docker.com, you would actually get the entire documentation around that. You could also just type docker help here, and it will tell you all the list of commands that are available to you.
So the whole thing's called a Docker.
Yes. Yeah. So Docker is the whole framework or ecosystem. Yes.
Okay, so can we try to quickly do a mock of this, a mental mock of this code? We do have a capstone project that we are deploying now.
Yeah.
That the client puts an ETF code, a ticker, say QQQ. It goes to Alpha Vantage websites through an API, grabs the data, runs an AI code, and outputs a prediction.
Yes.
This prediction goes to a database that is going to be captured by a front end and is going to be displayed.
Correct.
So, with the Docker, we would have one first router that the client is going to see a web page. They're going to put a ticker there.
Right.
It's going to press enter. This will lead to another slash, let's say,
Right.
model.
Yeah.
It's going to input the QQQ, the ticker,
Yeah.
goes to Alpha Vantage, runs the model, have the output, and outputs a third page
Right.
that is the result.
Yeah. So I think we'll have to think about it, but yes, it's doable. Maybe you could have like 3 microservices, one dealing with Avantage, to pull the data, another to pass that data into the model, run the model in that container. Third could be to display back the results on the front end.
So we would have just like that, 3
Yeah.
Dockers,
Yeah, 3
one
Docker
each is going to have a microservice,
Yes.
and they're going to communicate and output it.
Yeah, exactly. So you could do like, I haven't seen the Noah's application yet, but let's assume that he has,
No, that's a-
he's putting a simple front end.
Yeah, just a chart,
Yeah.
just a time series chart.
Yeah, so
with
in
the
that web
prediction.
page, on the back end, basically there could be 3 containers, and each of the container you can scale up or down. So these 3 containers are the services. One will do basically pull the data from Avantage, Second, we'll call the model with that data, and third, maybe present that back onto with some.
So that if both of us enter at the same time, I put QQQ, he puts SPY.
Each is
So
supported.
this will be these containers will be duplicated.
Yes.
So each one run one thing.
Yeah, they are stateless completely. Yes. So the way it will work out is because each of this user session will have its own token.
Mm-hmm.
So that entire instance of that run, that specific container will be tied to the token. So when he's running for QQQ, that service will go, it will invoke like one instance of service 1, second, another instance of service 2, and so on. And then at the same time, you're also going in and you're trying to do QQQ or something else. It will keep track of your session as a separate session and will spawn another image of the same container.
So who is managing? Is the Docker managing all this?
No, so
session?
in an ideal world, we want to use Kubernetes. So last time we spoke about Kubernetes in the last class. Kubernetes is an open source, basically it's now open source software, originally written by Google. What Kubernetes does is it allows you to manage the entire infrastructure. It provides you everything, including the scaling, orchestration, creating, increasing the memory. Important thing is about like all these containers we haven't spoke about the file system, right? None of this diagram I have said that they have file system. With Kubernetes you get a file system, a same common file system that every container will have access to. As an example, it's called persistent volume. So Kubernetes provide all of that. And beauty of it is like all of the Google's infrastructure. Google has millions of computers all over the world. All of that is managed using Kubernetes. So that's why. So we're going to talk about that when you go to the next slide. But let me just kill this container. It's okay even if I don't kill, but these are the command, right? So I just want to show you, if you want, you could say Docker, you can just say stop. This is the container ID. And it's gone. So now if I try to, it's killing it, just give this a minute. Okay. Now if I try to go back to say just a V1, it's a site can't reach. It's done. Alright, that's the video of the containers. Okay. Alright, let's move on to the next one.
So far there was no Kubernetes, but the Docker was managing everything.
Everything was, yes, exactly.
Now
So-
with the Kubernetes, that's going to manage Docker.
Yes, yeah. So actually when you go into this, there's one more. I was talking to you about GAE, which is the PaaS equivalent on Google, which is called Google Application Engine. You guys can try this at your leisure at home. These are some quick start examples on how to deploy to GAE. But this one is real. This is the Google Kubernetes engine, which we're going to go over. So before that, quickly, what this does is, and at least it will give you guys an idea. I'm creating, using the same application, but everything on Google. Okay, I'm creating a container. I'm creating a cluster. Okay, at least 2 nodes cluster I'm creating. I'm deploying those containers on that cluster. I'll show you how to scale up or down. And literally, I can also expose them, and that's part of this demo as well. We'll get a public IP address, because that's one of the key things you want to learn. So that, from your local web browser, you could connect to that container running on Google Cloud.
So then there is no Docker required in this one?
There is.
Okay.
So the whole thing is, Docker provides the infrastructure for creating the image, for creating the, whatever software you have, It allows you.
Just, explain how they.
Okay, sure.
Sorry.
No, that's fine. So basically you have, this is your app, okay? To create this app in a sandbox, to push it in a sandbox, you need an image, right? So you need an image of this app, right? To create the image, you need Docker. Okay? Okay. And then, once you have the image, right, you need to store it somewhere, right? Typically, what you need is something called as a repository. Okay, there are multiple repositories. If you go to Docker Hub, the most common is Docker Hub. Google also has it. I think, and we're going to use Google Cloud Repository, GCR or something like that. So we're just going to focus on two. So this image will go into a repository. It has to there. Why? Because you want to scale it, right? You want to have as many replicas as possible. So that's why the image needs to be there. And then, so this is just about your app. Your app, your image goes to a Docker repository. Yes.
So even if you run Docker on your local machine, actually the images is stored on like.
On my machine.
It's still on your machine.
On my machine. Yeah. So there is one
It's not
command.
like the Docker Hub is actually your own on your own machine.
No, Docker Hub is on the cloud somewhere. So this repository is similar to GitHub, right?
Yeah.
You know GitHub. GitHub is somewhere sitting on the cloud.
Yeah.
It's a.
That's why you said like image stored in the Docker Hub.
Yeah. So that's because this way we intend to run it on the cloud, right?
Yeah.
So from the cloud, it's not going to go and fetch the image from your local desktop. It needs to fetch it from somewhere, right? And that somewhere is also a cloud, like your iPhone, right? Sorry, yeah.
But if you go back to the first slide,
Yeah,
you're sending everything to one computer
correct. Yes,
that actually doesn't just have the operational system,
that's right.
right?
Yes. Let me go back to that slide.
That's the idea.
Yeah, exactly.
And then it's going to run there. That's what you are pushing. You're sending this to a computer just like yours, but
Yes.
that is going to be connected all the time.
That's right, yeah. So here, like if I run this command, right, I can literally push this image that I built to Docker Hub. Docker, when I call Docker push, it goes to Docker Hub.
Oh.
It takes it from my local disk and then I can remove it. I don't need to have anything on my local.
Does that mean there are like two copies? One is on your local machine, the other is on the Docker Hub?
Yeah, it will be if I push it.
Gotcha, thank you.
But right now I haven't pushed it. But as an example, I was showing you, right? Where is it? So here I have Docker Hub open. So this is my repository. Okay? And this is what I have posted here. So just one image I created. Just to see whether it's working for me or not. But similarly, I can have
the GCR, right?
no. This is on Docker Hub. This is the Docker Hub for Docker containers.
Is there a public side in the
Yeah.
Docker?
Yes, it is.
So how do you go and configure it?
So right now I made. If you look at this, I purposefully kept my my repository as private. The moment you make it public, anybody can go and pull out that image. So in fact, if you go to just dockerhub.com, you would see a lot of good software there.
But if I want to go for like let's say my private company, right?
Yeah.
Still go and put in the Docker same place or?
Yeah, you can. All you
have
can do is
access
keep
to
it
the-
private. Keep it private.
Not just private, but what I'm saying is, it could be like a financial firm, right?
Yeah.
And then how do you go and push, what will Docker push do?
So there are a number of things. This is right now encrypted here. It's sitting there, but it's
Yeah,
encrypted.
sure.
You could add more security. You could add like a extra encryption on top of whatever Docker is providing. So whole thing is like, remember this thing. The Docker is so successful because it provides you a clear boundary. Like, think about it like, who was it, Amazon recently lost a lot of data or something, right? Yeah, because someone had access to the EC2 instance and they pull out. With the Docker, it's not like that. There's a very clear boundary between two containers. They have to do it. Otherwise, Dockers won't work.
I understand, but how can, the big organization can trust Docker?
They can have their own repository. Like where I worked or where I used to work or even the present job, we have our own repository. We keep
So
all
Docker
our-
push, you can configure it to push somewhere else.
Yes,
That's
exactly.
what I'm saying.
Oh yeah. Sorry, I didn't get
Yeah.
that. Yeah, you have that option.
Okay.
Docker is just a utility. It's a utility. Wherever you would like to push and all, the repository could be yours.
Exactly.
I
Yeah.
thought so, it's just like.
Oh, okay. Sorry, I didn't get that. But yeah, you could say Docker push and then
Ah,
it will tell you the path, which repository you want to use.
okay.
Okay.
Okay, right, okay.
So
Sorry.
that's fine. Going back to okay. No, this is done. Okay, this one. So what's the time now?
7:41.
So we have 20 minutes. Okay. Let's see how much we can do. So this one, and we open the Google. Alright. So at the minimum, what I want you guys to do is at home, sign into Google account, alright, and follow these instructions, okay? Create a GC project, and I have some, I think, well, no, let's do it for now. So you create a GCP project, which is basically a Google Cloud project. Give it some ID, and I'll quickly show you the demo. Like here, I created my first project. So if you go in here, so like this is the project I created, but I can create for in front of you guys. Say call class project, and it has to be unique, okay? And project 1, okay? Fine, it says open. No, sorry, I did create one. I call it as a new project, and I can call it as class project 2. Okay, and say create. So it's creating this project. Billing is enabled and all. This is all automatic. Okay. So once you go into this console, which is Google Cloud Platform, it will pop up all kind of prompts for you. Just follow them. Making bigger. So I select this one. All right, and then I said here. Billing is enable the API. So if you go into the API section, and even if you don't do that, as you make progress, it will tell you. Where is the API? Oh no, that's it.
Right here,
Right there.
underneath that.
Oh, okay.
API request.
Yeah. So API and services, So I think I have some APIs enabled already. If not, it will tell me whether. So you click on here and it will allow, ask you to what APIs you want. So I have some APIs that I've been using frequently that are all enabled, like Input Engine API is one that we're going to use. Cloud storage is the other one that we intend to use. I think those two. But yeah, you look at it, there are a lot of PPIs here, and you can figure that out, including some of the AI, ML kind of APIs also there. The same thing that whatever Amazon offers, Google has equivalent offering. Big data. You go through those categories and you will find that. So going back to the console. Okay, so this is the important thing, activate the cloud share. Because everything that we're going to do is going to run on the cloud share. So here is the icon for that. Okay, you click here. What it does is it's going to create an instance for me and can populate everything that I need. Okay. So in here, it recognizes this is me, so because I already logged in. But typically, you log in here because this is my account. So it says which project I'm going to use. So this is class project 2 that's active right now, and which is we can use that one. Next thing is building this container, build and validate container. So whatever I did in earlier, right? The same thing. So let's look at some of this. Let's make sure project ID is already set. So there's nothing. So I'm just going to run this command. Okay. So it says, if I do now again, and you can use upper arrow, down arrow key. Class project 2 is now set. That's my project ID. And of course I want to use a zone, right? So just remember that in this case, so similar like Amazon, right? We have
Project ID is nothing but your project name only, right?
correct, yes.
That was already set above, right?
No,
Cloud
in
platform
the shell.
session is set to class project 2, right?
Yeah, but see, we are using the Google shell, right? So there are two ways of doing stuff on Google Cloud. One is you could use this, this whole of the website. There are various services. The other one is the Google shell. Google shell is the easiest one, trust me, because otherwise you have to navigate through all this, menus, sub-menus, and you have to pull out the specific action. But the Google shell is very straightforward. Same thing with Amazon. Amazon has its own, command line interface that you can type like this on its website, and also you can do similar menu, sub-menu, kind of stuff, and go through this, whatever you want to do. So here I'm going to use, East 4 is Virginia. A is just the zone, it has a.
So what are you configuring here? G-Cloud?
G-Cloud is a utility. It's a command line interface for all of the Google interfaces. Similar like in Amazon, you have what is it? I don't remember what it's called. AWS something. In Google, it's called G-Cloud. So every other provider has that similar stuff. Okay. We're going to build an image. Oh, so before that I haven't downloaded the code, right? So again I'm going to do that. I think here git clone I'm going to do. Oh, so it's already there. Okay. So we don't have to do it. Okay. Somehow I didn't deleted that, which is good. Right. And Docker build. So it's building a new image for me of, we call it class project PSOI. Okay, anyway, we'll use that. So remember the GCR.io I was telling you?
Repository.
So this is Google's cloud repository. That's the address for that. So it's saving it at the GCR.io. Okay,
Oh, just, I could not download.
what? Oh, did you did it git
No.
git clone?
No,
Oh,
yeah.
try it out.
So Docker builds GCR.
Yeah, it's the same command here. Docker
Look at.
build -t is a tag. So this is the tag, from class project PSOI/bootcamp. Column V1 is our version 1. Dot is for build it from the current version.
Okay.
Alright, it's successfully built. This is our image ID, and it's successfully tagged it with this name. Alright. So this is ready. Now, Docker image ls, just to check whether how is our image, whether it's created or not. So I can just go run this command, and it will show me what images I have created so far. So this is the image I had created just now. Okay, 41 seconds ago. This sometime back, I think I had a Python older image because it needs a base image. Remember Docker file? It had the base image as Python 3.7, so it's still there. It's reusing that image. Okay. Then you, as I said,
So you do need the Python image there?
yes, I need, because I am using Python 3.7, right?
Right.
Typically what happens is all of this application, they have ready-made images. I don't have to do anything. I just, similar to inheritance, like object-oriented concepts, you can inherit that existing Python 3.7 image for your, so that becomes a base image. When you look at there is a command, I don't remember what it is, but you could actually, once you create an image, you could go into the content of image, and it will list every component of that image, like which is taking the maximum space and all of that. So you can easily figure out which part is your and which part is pulling from the web.
So in this case, you don't need your own VM at all. You are just simply using the Google Cloud services.
Yes.
And but for the Google Cloud service, we don't know what the standard Python could be.
Yes, you have to specify, right? In this case, I'm saying I am going to use Python 3.7.
Right, I got that. But
Yeah.
suppose if you don't care about any particular version, what is the standard Python version?
Yes.
It should have it, right?
Yes. Yes.
So I really don't need to download them, and then I can get rid of the Python
Yeah.
configuration.
Yeah. You don't even like this particular app. Actually, I was comfortable running on Python 3.7. That's why I kept 3.7.
Right.
But whatever version you have on your desktop, if your app runs there, you can go ahead and use it. Alright. Next thing is, so in order for you to push your image to Google Cloud repository, you need to authenticate. Since I had already authenticated, it's not going to ask me to do anything. It says credential are already registered, so I don't have to worry about it. Now I'm going to push this image. So this is the command I was saying, like Docker is pretty much the framework for the diagram, creating the image, pushing it to the cloud repository, and bingo, it happened. So it's already, it's also encrypted, it's SHA-256, so it's protected.
Did you push the Python image as well?
Yeah, everything,
Wow.
all of that is gone now. Size is, I think it's a key size, maybe 2843. I don't know, it's 2843, it's 2843 MB. Or KB, maybe not, it's not more than gig, so it could be KB. So it's actually fine now. Okay, now next is just run it locally to see whether it's runnable or not. Okay, the same thing that we did, but this time we are running it on the Google. Alright, so it's running here. You can test it. Open a new shell cloud, or I can go on to. So here there's a web preview. You just press and say which port I want to use. 8080. Remember here I changed the port number. Just take a note here. I used 8080.
Yeah.
This is my host port versus the container port is 8890. Okay? So when I say web preview on port 8080, it will pop up here and I could just say E1. There you go. Alright? So quickly, this is running on the web and you have access to that container. Alright? So now, this is still just a localizer. You haven't yet touched the other part. Alright, so this one is running. Let's go to, these are some snips of the stuff that we have been doing. So let me just, I kill it. Okay, then deploying an application. So this, you guys can go through. So next is create a container cluster. Okay. So what I'm going to do is I'm going to create a 2-node cluster and name it as myself, Ron cluster, so that it is easy for me to remember. Okay, so let's try that. Alright, so it's creating here. You would see things. Oh, what happened? Oh, I haven't enabled for this one. Engine API is not enabled. So all you have, so similarly, when you try this, you will have similar kind of errors. So just go and click on this. So here, if I click this, so for this under this project, I haven't enabled Kubernetes. So I just say enable it. All right. So why Kubernetes now? Here's the importance of Kubernetes. Kubernetes is actually the middleware that allows us to create the cluster, manage the cluster, provision the cluster, and do all sort of generally. So up to prior to this point, it was all Docker. Now everything is handed over to Kubernetes. So from that point onwards, it's Kubernetes' responsibility to manage everything for you.
Basically, we are going from development to production.
Exactly. So I haven't asked. Do you guys have any questions so far? I mean, are you guys getting this? It's important, that you. The takeaway for me is that you guys have, at least introductory knowledge about containers, deployments, and so on, so that you guys can go and play with it at home. Sorry, go ahead.
So this cluster creation, once you enable and everything in the cluster, that 2-node cluster that you said, right?
Yeah.
Is going to again create a separate cluster for you, or is going to utilize the existing cluster?
No, it's
to
so
expand your service?
so I deleted my older cluster, so I'm it's going to create a new cluster for me.
Isn't there like too much overhead just for few of this microservices?
Yeah, that's fine, but this is just for
No,
a
I
demo,
understand
right?
that, but in general.
In general, no, I don't need 2-node cluster. I need just
No, but even if, for example, if I need to have a 2-node cluster, right?
Yeah.
Can Google provide us, a slice of the existing clusters?
Yes, you can. But think about it, these are like just single.
Just like the way I'm comparing,
Yeah.
it provided our,
Yeah.
the simple shell, right, by, so
Yeah.
it's not like a separate VM, it's probably
Yeah.
using existing
No,
stuff.
but no, that's a difference in concept.
Right, that's what I'm
When you
asking.
talk about clusters, or even the EC2 instance in Amazon, the instance is nothing but a virtual machine.
Right.
Remember like this,
Yeah.
like everything on the, even like when you say you have a dual core, right? If you have a dual core, this is probably quad core on this Max.
Okay.
So there are 4 cores, right?
Right.
Each of this could be VM. VM1, VM2, V3, V4, right? So what Amazon does is, it takes this as a VM and say this is your instance, this is your virtual machine instance.
Right.
It's not a physical box.
Correct. Yeah.
So on this VM, this is one single CPU, one core. You could have as many containers as you want.
I know, but I'm just saying that for my microservice, right,
Yeah.
it would be best, that, it doesn't go through the long
Oh, yeah,
process
yeah,
creation,
yeah.
cluster and everything.
You can be
Rather,
a
it just
tenant.
gives me existing one and then I can be up and running right away.
Yeah, you can turn off.
Okay.
Yeah. It says co-tenant or whatever,
Okay.
so that you could literally
I guess.
coexist with other guys.
Right.
So if I create a project on the Google Cloud, just as what you did just now, so I still couldn't have a public URL?
Yes, you can.
I did, so how?
Yeah, so that's the part one. Quickly, let's go through that. So I enabled it.
Yeah.
Now let's have the cluster. Okay, so it's creating it on UC. So it's almost here. And it will show up on the top, so you'll see that the cluster gets created.
Yeah.
Oh, so I have to, this cluster actually generate that URL?
No, not yet. There are a few steps, and we'll come to that quickly. How much was the time? So, are you guys okay staying like another 3-4 minutes?
Yeah. Yeah.
Okay. So just.
20 minutes, no problem.
Alright.
This is interesting.
Yeah.
Okay, so it's being deployed. So this is the beauty of Kubernetes. See, if I have to do this on Amazon, it will probably take me a couple of hours, at least. Because then I have to spawn one instance at a time, I have to create a cluster, pulling all of this together, putting all the security policies, who is allowed to access the cluster, what IAM role I need. All of that will take more than 2 hours. Then the first time will probably take a day or so. So with the Kubernetes, it's so easy. You just run one command, it takes everything, it takes care of everything for you. So cluster is created, it's checking the health. Yes.
Yeah, so you mentioned that you would have to create IAM users.
Yes.
How this would work in here? Let's say I have a team,
Yeah.
we have some roles.
Yes, you can. So right now it's created because I am the only user.
Yes.
So it just takes me as the user and puts my as the only owner.
Okay.
But if you want, you could share it. You could create a team. With multiple users in it, give them access. So here everything is controlled at the project level. So that project we created first time. Basically, at that project level, you put in all the users that you want.
So that becomes the same only, right? Then the AWS also you are doing the same. It's more of you are doing the configuration before.
Yes.
Yeah.
Here we are going to do the configuration later on. Whatever
Well,
access that you would like to provide, you will be providing it now, right?
Yeah, but I think even there, here it was straightforward, right? Just specify a project container, and that's about it. With the AWS, I think at every step, it will stop you and say, okay, you need to. So I'm creating AC2 instance now. Who has access to? What's the VPC policy for that? Which IAM will have access to deploy to that? So all of that you have to set it up. I don't have to worry about all of that thing here. That's the beauty about it.
No, there also it basically pops up the default values. So either you can take the default values,
Right.
whatever the existing user or something you keep on taking that, or you keep on configuring it, right?
Right. So, yeah, something like that. But let's go through this quickly. Oops. Forget about this. But you see that it's already created. I can run this, and it will give me the instance list. Okay. So two instances are created. All right. So notice there's a public external IP also there, but we don't care about it. We want the load balancer, okay? And the next one, this is created, so deploy the application. So kubectl is the command to deploy, kubectl is basically the command line interface to interact with Kubernetes. Okay, it's just very rich, similar like Docker. With Kubernetes, it's kubectl, right? So I run this command. And it's doing a deployment. So what it does is, it created a deployment task called deploy bookap. This is the image. You remember this image we created earlier? And then it's deployed. Okay, it says it's created that. Now I want to see whether validate this deployment. So in Kubernetes, remember all those small earlier I said there's a container. They are called pods. The terminology is pods. Okay, so you could have a swarm of pods, which is basically many pods. Okay? So get pods, and it will show me it's already ready. Okay, it was created 39 seconds ago. So we created just one single pod. Okay. Now I'm going to expose. Sorry, I'm going to create expose this deployment to a load balancer. So that you can have access it from the internet. So remember what I did was I said use the port number 80. Target port is of course 8890, which is the container port. But for the outside world it's port 80 now. Okay. So there you go, it's exposed. I can just see, now I need to know what's the IP address of the load balancer. So all of you guys have to hit the load balancer. Okay. So it's creating, it's created the load balancer. Now it's hadn't populated or assigned external public IP. So it's doing that. Run it for multiple times, and you'll see it in a minute. Not yet. Okay, there you go. So go for it. Type this thing on the web page. Here I do. Yeah. No.
No. Can do.
There you go. Looks like /v1 http.
Refuse to connect means we need authentication or something?
No, it should be
Refresh.
cluster IP. Which is the IP? External IP is this one, right?
Do I need to have the
Some
port
firewall.
number? Do I need to put the port number there?
No, not required, but let's try that. I don't know why, maybe something is wrong. It's already exposed 80 and so it should be.
We should be able to use the individual IPs also, right? The
No, but
previous
load
instances.
balancer is what, this is the cluster, you don't
No,
need
no,
to-
not that. When
Yeah.
you created those two instances,
Right.
it assigned to external IPs.
Yeah,
Want
you
to
can
try
try
and
that
check?
also, yeah, but these are similar, I think the library might have a firewall, I
They
don't
will
know.
know whether load balancer or
Let's see this guy, I'm going to give it a try. Let's see.
to give the port number, the one which you assigned.
Try that.
8090, right?
8090 something.
8090.
Yeah, but 8090 was internal.
Really?
It won't be exposed.
Right.
8890. It's trying, but I don't think it will go through because that won't be exposed directly. It has to go through 80. You guys can try it as an exercise, but basically it worked for me from my home, so I don't know why. It's giving me a problem here. Let me try one more time.
Do you want to ping it? Maybe the library firewall.
Well, one thing I can do is I can do.
Can you trace it out to find out how far it goes?
Yeah. I don't have a command here.
Or just ping.
Like this?
Yeah.
I think I'll have to, because this is a new installation. I
Just
need.
try the ping, I think so.
Let me see, Carl. Failed to connect. Connection refused. I think it's refusing the connection from there. Yeah. So it's refusing somehow. So something is gone wrong. I don't know what. But anyway, you guys get the idea, right?
We've all been there.
Okay. Yeah. So you guys can try this out at home.
Yeah.
And it should work, you know. I mean, at least for me, it works straight.
You're right.
All right, so one last thing, yeah, please go ahead.
Oh, nice, all you've done, I'm just asking the time for the next class, it's all.
Oh, yeah,
Saturday
yeah,
or
so,
Wednesday?
hold on, let me just bring down the cluster quickly before I forget.
Quick question, how the cost works out here?
Yeah.
How is the cost works out here?
It's similar like Amazon,
Generally
once,
like for an hour or something?
yeah, well,
How do you cost per hour?
I think few cents per hour.
You don't use it. Yeah, you can, that will stay forever.
I'm just trying to check the
You will make sure
$300
that it's-
credit, how long it will turn it off.
Yeah,
Cluster will
so I'm deleting it, and then I'll say delete the cluster also.
It's pretty good, you know, to be a practical, you know.
Oh,
Yes. So I'm deleting that cluster.
Right now,
So let's talk about the next class will be on Saturday.
24.
Yeah, not this Saturday.
The other side.
Yeah, what's the date? I think.
24.
24.
Yeah, 24.
You're 2 days, right?
Yes.
Saturday and Sunday, right?
No, we'll have Saturday, this Saturday and the following 21st.
Oh, yeah.
24th and 31st.
24th and 31st.
What time is it?
he said.
What time?
Mm,
9:30 to 11?
I think what time this Kelsey said, 9, right? I don't know. We will communicate on, I think it must be on the
It's there.
meetup page.
No, it's not.
It's
not?
it's
Not yet.
okay for everybody?
It's not. I'm going to post everything, all the meetups.
Saturdays, yeah, Saturdays 24th and 31st, the timings are, I don't know, so we'll probably update you guys. Saturday
I
maybe,
think it's up to you.
9 a.m. is good,
9 a.m. for me.
9 a.m. for you guys. So actually what the next class maybe we can do is doing deployment to Amazon,
Okay.
right?
This
Or
would be
if,
great.
or if you guys want to do a project, we could do an actual project, you know. So you guys need to have some working code.
Well, let's try to let's deploy the code for time series. What do you think?
Alright.
We are going to have deployed that already. It's already deployed on Amazon, but actually we can.
Yeah, I don't
We
know
can
the
do that.
current status, but yeah, I'll follow up, was it John?
Yes.
Okay, I'll pull the code from him.
Okay. Well, we can do that. So
Maybe
yes,
we can do both on Saturday. Can we like do a little bit longer class?
but do what?
Both, like both on Amazon and the real instance.
No, but we're going to have 2 Saturdays.
Exactly.
We're going to have two Saturdays. What I think the best way to do for the next class, what would be the most productive thing to do is for us to try to deploy something,
Yeah.
and we're going to encounter a bunch of doubts and problems and questions. We bring them to run on the 24th, so we can actually polish the Google Cloud. And probably you know this, but Amazon is going to be just in one day we can grab, because we already have every single concept. I don't know, 85% of the concepts we've learned here. It's going to just be a change of names and things like
Yeah.
that.
It's better have at least like a quick glance of it so we can do the
No,
comparison.
yes, definitely.
Yeah. that'd be-
Not have the comma.
Correct. Let's have a round of applause. Guys, thank you very much.
Thank you.
So next Saturday, 9-ish, okay? Is that okay?
Yeah.
Okay.
Yeah.